Hello guys, and welcome back to Joe's Ventures, and today we're doing another episode of our Jurassic World Evolution 2 mod spotlights. This will be part 95, where we take a look at some of the wonderful mods people are making and compare them to their real-life fossil counterparts. So today we've actually got quite an interesting assortment. We've got some kind of remasters or, new cosmetics to bring a new look at these animals. Also got a few new ones, and then we've got our Reptileano, which is, I don't think he's actually going to release this before the video comes out, but he's given me, at the moment, at time of recording, special previews of a couple of mods that will be coming out soon. So I'm really excited to get stuck into that. So we're going to get started with, though, we've got one from Master Doot. We have got Nemegtosaurus. We'll have a look at you. I think you look in a funny posture. So this is Nemegtosaurus. So Nemegtosaurus, which means reptile from the Nemect, is a sauropod dinosaur from the late Cretaceous. This is from the Maastrichtian, about 70 to 66 million years ago, so that kind of time, and lived in what is now Mongolia in the Gobi Desert. So the animal itself would have measured about 12.5 to 13 meters, or about 45 feet long, and weighed about 20 tons. And it's got its name because it lived in the Nemegt Basin, which is in the Gobi Desert, and where the remains of a single skull was found. And the skull itself resembles that of a diplodocid, so, very long and low skull with peg-like pencil teeth. However, recent work suggests that it's not actually a diplodocid. It's believed to be actually a titanosaur, so it's actually more closely related to titanosaurs, things like Saltosaurus, Alamosaurus, and Repetisaurus. So this has got a little bit of interesting story. So Nemegtosaurus is originally known from a skull, and the skull comes from the same beds of a titanosaur that called Osteocollicoldia, which is known from a skeleton that lacks a neck and skull. So originally, Nemegtosaurus was considered a diplodocid, and Osteocollicoldia was considered a Camarasaurid, so related to things like Camarasaurus, while Nemegtosaurus was related to things like Diplodocus. And they were believed to be different things. But both of these genera actually were shown to represent advanced titanosaurs, which raised the possibility: are they actually just the same animal? So is the body and the neck, are they just the same animal? Because we have no overlapping bits. It could easily just be the same thing. Relocation of Nemegtosaurus type locality in central and discovery of both postcrania that was actually comparable to those of Osteocollicoldia, holotype to the Nemegtosaurus, has actually discussed the possibility of Osteocollicoldia being a genus synonym of Nemegtosaurus. Consequently, the group Osteocollicollidae was actually renamed into Nemegtosauridae. Though in 2019, there was a few people that they were describing new specimens of Nemegtosaurus that reanalyzed the argument to synonymize, and they found that it was not sufficient, or there wasn't enough shared characters, or it was either difficult to determine which actually belonged to Nemegtosaurus and things like that. So it's kind of hard with not a lot of overlap, but that doesn't mean it's not true. It's just we don't have enough evidence to prove it. So if you want to lump it, you're free. It's just whatever. But there's two different species. One was lumped. Nemegtosaurus mongoliensis was first described in 1971 by Nowoski, and the second species, Mpachi, was described by Dong in 1977, based on the teeth in the Shibashi Formation, but now that is considered a Nomanubian, or considered not correct anymore. So, the cladogram, or what's suggested here, is it's a group of Lithostauria, which is a group of later titanosaurs, and is related to things like it's in the group Nemegtosauridae, or the family, which includes things like Tapuisaurus and Repetisaurus. Repetisaurus is from Madagascar, so a kind of group of later titanosaurs, and then they went to Saurus, Saltosauria, and things like that a little bit later, but very basal in that group. So, as I mentioned, also found with Eustreptospondylus, these guys were a fairly small, or not a huge sauropod dinosaur. They got about 12 to 13 meters and weighed about 20 tons. And like other titanosaurs, they had pencil-shaped teeth that were slender and had a sharp angle that were chisel-tipped, so they're able to rip apart plants pretty effectively. The diet of Nemegtosaurus itself is unknown, as there are no really plant fossils from the Gobi Desert from the late Cretaceous. But based on other areas, there were lots of flowering plants that were diversifying at this time, but in other areas, ferns and conifers were still quite common. Neither is it clear if these guys were high browsers or low browsers, as their relatives, which things like Reptileano would have been high browsers, and short-necked Monostaga would have been potentially grazers. So it's really hard to tell. They could have been mixed. We just don't have enough of their anatomy to really tell. Another cool thing as well, comparisons of the seclural rings, or the rings in the eyes of this guy, and also modern birds and reptiles, suggest that these guys would have been carthermal, which means they would have been active throughout the day in short intervals. Very similar to like modern herbivores today, so that's not too surprising. So the paleoenvironment Nemegtosaurus was found in. Nemegtosaurus was found in the Maastrichtian about 66 to 72 million years ago, or around that time, which made it one of the last sauropods to live actually on Earth. There was a lush river delta flowing through the ancient sands of the Gobi Desert, and Nemegtosaurus would have existed with quite a few famous dinosaurs, things like Gallimimus, Mononychus, a velociraptorine called Adasaurus, and Therizinosaurus. It also would have lived alongside the T-Rex relative Tarbosaurus, and possibly being about 12 meters, it would have been a little bit bigger than an adult Tarbosaurus, but an adult could easily defend themselves against an adult Tarbosaurus. That juveniles would have been vulnerable. So potentially juveniles and adults would have been vulnerable to Tarbosaurus, which seem to have actually had special adaptations comparable to things like Carodontosaurs to be able to hunt sauropods rather than Tyrannosaurus, which had very big, bulky skull to have that crushing bite force to eat hard things like the frills and the bodies of ankylosaurs and ceratopsians and things like that. So yeah, a cool little bit there. This one was done by Massa Doot, making their return. The really, really awesome one there. So let the release you and let you do your own thing. So next up, we have got by El Reptilia, the whole group there. El Reptilio and Co. It's really a group effort with their mods, but El Reptilio has been the kind of the main figurehead of this one, did most of the designing and everything. So yeah, let's have a really awesome look at this accurate Camarasaurus. Awesome, I love this guy. So here we've got Camarasaurus, and I'll go through a little bit of the change anatomy and things, but you can see that scale detail is so amazing, and you can see it's changed a lot based on other dinosaurs. So we do have, from what we know of most dinosaur skin impressions, the scales weren't just the same across the body, because you can see here like the top ones, very much like hexagons or like pebbles. But you reach the bottom of the body, you can see they're very rectangular, especially along the tail there. And you can see there's some areas with some bigger feature scales, especially around that chest there, which looks really, really cool. And it's also got some little spikes going along the back, which is cool. We have a look at the skull, probably one of the bigger changes. You can see it's not super shrink-wrapped. So a lot of modern monitor lizards have their nostrils around the front of their nasals, even though the bones are at the back. So they have the kind of this big airway here. Could have potentially used it for, sounds, or to help potentially keeping their bodies warm or cool, depending on what it needed help with body thermoregulation. And, just means that they weren't so far, close to the bone, because I love our reconstructions, especially from the 90s, being so shrink wrap and just hug the bone. So that's not an issue anymore, which is really quite cool. And you can see all these fenestrae, you can't see them anywhere. But you can also see here, what's really cool, we do have a Camarasaurus skull with cornified skin around its lips, quote unquote. It is very much cornified or keratinized skin, how it's been interpreted. It wouldn't necessarily mean it would be like a beak. It's not a beak, it's not the same as a Ramphitheca. It is literally not the same thing, but it's like almost like a hard lip that almost like, you know, kind of evolved to be similar to that, because they've still got proper teeth and everything. Would have probably helped, you know, with going in branches and thick trees and things like thick leaves and branches, things like that. Probably helped to protect their skin a little better. Be a really, really awesome and, you know, lovely eye there. And you also see that the neck is, you know, nowhere near as thin as it was, not so spindly. You can see it's quite thick with lots of room for, you know, blood vessels and arteries and the trachea and all these muscles and ligaments that would have to hold it up at this angle. But I also really like a lot of these fleshy skins bits there. It gives a lot of detail to it. A lot of, you know, necks can be quite, you know, wrinkles and everything. Looks really, really awesome. And then we'll move down to the body. You can see, you know, big boxy body, held its head up high. Camarasaurus, you know, being kind of a mid-hub browser in the ecosystem of the Morrison. And then you can see these lovely legs. You see the big features scales along the shoulders there, which is really awesome. You see these long columnar legs coming down here. And you also see the feet. So no, none of these big claws like the original one. Most of these Jurassic kind of sauropods would have had horseshoe-shaped kind of feet, front feet with a claw. Some later ones even lost some of their digits and kind of started just walking around like their knuckles and things like that. Though they weren't true knuckle walkers, they were just that well adapted to just support their weight. And you see that long columnar legs coming in there, which is really cool. And you can see, as I mentioned, the change of scales. You can see around here it gets quite rectangular, and on the bottom as well. See these back feet are, you know, correct as well. They've got the 3 big claws. They're actually quite similar to those of modern giant tortoises that are curved, so they can actually dig out nests and things. And also it's got this big fleshy pad that helps support their weight. And you can also see there the underside of it with a cloaca. This actually does have a cloaca, as you can see there. Very, very interesting. And then you can see the more wrinkles and things like that, and there's different scales along the body as it goes out to the tail. And Camarasaurus would have a particularly long and interesting tail, but still awesome to see it regardless. And definitely just a big fan. Just bloody awesome. It really, really is. I love seeing some nice scale detail on these guys. And you look, just how it makes it look, you know, not quite so flat when you can see some areas with big scales and small scales. And yeah, it's another knock out of the park for Reptileano. Did a really awesome job at Reptileano & Co. You know, these are very much group effort because I believe he commissioned someone to model them. Don't know exactly who, but they do a phenomenal job. Just everyone involved just did a phenomenal job in giving us a really awesome mod. So we'll let them run off and do their thing. Next up, we've got from Sarcosuchus. Has actually made some new cosmetics, so going back and redoing some of their models. But you'll still need the original mod or for the species, but these cosmetics will add those extra cosmetics, so you get the second generation, is what he's termed it. So this is the new updated version of what he's made, which is quite interesting. So we've got a few different species he's gone through and kind of redone. We've got here Ornitholestes, and I'm not going to make the same mistake as the last recording. I'm going to release them via airlift because that's what they need. So let's just release them all. Here we are. So this is Ornitholestes, Generation 2. So Ornitholestes, which means a bird robber. These guys are a small theropod from the late Jurassic and the Bushy Bay member of the Morrison Formation from the Middle Cambrian, which is about 154 million years ago, and is from Western Laurasia, which is Laurasia, was what would become North America. So to date, Ornitholestes is only known from a single partial skeleton with a crushed skull found in Bone Cabin Quarry near Medicine Bow, Wyoming, and then in 1900, and then it was described by Henry Fairfield Osborne in 1903. An incomplete hand was actually later attributed to Ornitholestes, though now appears to be things like Conoglerus, we say that. And the type and only specimen known, species known is Ornitholestes hermanni, which honors the American Museum of Natural History preparer Adam Herman. So we won't go a little bit to that, but we'll talk about Ornitholestes. So, in its original description, it was wrote the left Ornitholestes was about 2.2 meters, or about just over 7.2 feet long. However, this reconstruction is inaccurate based on Marsh's things, the restoration of the base of sauropodомorph Archaeosaurus. Most modern estimates suggested to be about 2 meters long, maybe a little bit over 2 meters, and about 12 to 15 kilograms, so not too huge. It was a bipedal carnivore, with head being proportionally smaller than most other modern predatory dinosaurs. I've looked actually from this way. But its skull was heavily built, with a short snout and a robust jaw, and you can see the orbits are quite large, measured about over 25% of the skull's length, and there's no indication of a bony eye ring. So the front teeth of Ornitholestes are somewhat conical, with reduced serrations, and the back teeth are more recurved and more sharply serrated, similar to other theropods. And one of the interesting things as well was originally the area of broken bone was thought to have bulged upwards. So Ornitholestes was originally interpreted with having a nasal horn or a cone, as you've seen in a Walking with Dinosaurs, but that is now considered to be not the case. It was just a bit of broken bone. Also had a relatively short neck, with a simple curve, with a long whip-like tail that actually had half the body length. It had about 9 to 10 cervical vertebrae, 13 dorsal vertebrae, 4 sternal vertebrae, and about 39 to 44 tail vertebrae. The forelimbs as well were relatively long, slender, and under 2/3 the length of the hind limbs. The humerus was heavily built, but somewhat longer than the radius and ulna, which is interesting as well. And it's often portrayed as a fast, long-legged theropod, but its lower limb bones are actually fairly short, which is only about, with the tibia with about 70% of the length of the femur, which is interesting as well. And there is some evidence to suggest that it may have had a modified sickle claw, some of that of Deinonychus. However, the poor preservation of digit 2 makes it hard to claim. So it could have had a sickle claw like this, but it's equally as likely that it didn't. I guess it's kind of, up to interpretation, one of them things. So the classification, or where it fits in the family tree, it fits in Coelurosauria, which was kind of a waste bucket taxon, but now has kind of been changed and split. This was considered to be a Coelurosaur, and it was thought to be a primitive member of the group Maniraptora, but it's thought to be even more basal. So the following kind of most evidence suggests that it would have been a Coelurosaur, but it would have been in the group Tyrannoraptora, which includes Tyrannosaurs, and then most, kind of Maniraptoriformes, which include Compsognathus, Ornithomimids, and Maniraptorans, so birds and velociraptors and things like that. So it's kind of in between T-Rex and then in between the Maniraptoriforms and Compsognathus. So it's kind of a little really weird in between species. So that's kind of where it fits in the categories of everything. What is these? Anyway, the biomechanical study conducted, actually, as I mentioned, they've actually kind of looked at the motion, and when flexed, they could actually move 53-degree angle, and it was a little bit more agile. Was actually considered, and this is a characteristic that is found in later Maniraptoriformes, but not in Allosaurus and Coelurosauris, which are later species. So this is very much potentially, kind of started to evolve the flexibility. In terms of its diet, there's been a little bit debate about its diet. They noted that it could have actually been thought to have been more carnivorous, but more transitioning into a more herbivorous lifestyle, which is interesting. However, most recent evidence, and most people suggest it would have been potentially just eating, lots of little things like small vertebrates, like, small mammals, small birds, small lizards, small frogs, things like that, or hatchling dinosaurs, which all been potential prey. And there's even some suggestions it could have been a pack hunter, but no. And there's actually some people actually suggesting that it would have been niche partitioning, because it would have been competing with things like Coelurus, and Ornitholestes may have been specialized for night hunting, but it's actually, it's really hard to tell. It's just a hypothesis. And they actually estimated, Paul in 1988 estimated that a 12-kilogram endothermic or warm-blooded Ornitholestes would actually have a daily dietary requirement of about 700 grams, or about 1.5 pounds of flesh a day. And in terms of feathers, It is hypothesized that they may have borne feathers. However, this was highly disregarded for most of, over half a century, with most reconstructions giving them, scaly skin. And then they actually, Paul and Robert T. Bark actually predicted feathers on these guys. And then there were things like Sarcosuchus were discovered. But based on the phylogenetic position of Ornitholestes, it would likely have been covered in feathers, except maybe on the legs, but have a short coat and would have had feathers as well. Though we don't know if it would have had pennaceous feathers like on the wings. That's kind of unlikely, but that is still potentially a possible interpretation. So this is definitely a possible interpretation. It's just, we don't know kind of thing. And long feathers lining the skull. So at minimum, it would have probably had something like Sarcosuchus, just a simple coat of feathers. At most, it would have had something a little bit more maniraptoran with, wing feathers and things like that, very similar to the things like Velociraptor and Ornithomimus and things like that. So that's very possible. So this is definitely a possible, albeit more derived reconstruction of Ornitholestes. But yeah, bloody awesome. Very much looks like a raptor, but, it's not quite there yet. It's on its way to becoming, something like that. But yeah, really, really awesome. Nice to see Generation 2, as I mentioned, next generation. So let it run off and do its thing. Next up, we've got another one done by High Squawk Tree, of course. We have got Eustreptospondylus, that famous one from Walking with Dinosaurs. So let's have a look at this guy. This is another Generation 2 one. So this is a good one. I like that color there, like that one, with the black and yellow, black and yellow. Don't copyright me for that. Anyway, here is Eustreptospondylus, which means an ancient Greek well-twisted vertebrae. So this is a group of megalosaurid theropod, or genus of megalosaurid theropod, from the Cavonian and Oxfordian stages of the Cretaceous, in the Jurassic, so between 166 and 154 million years ago, in southern Europe, which at the time was actually a bunch of scattered islands, which is quite interesting. Very interesting history for this guy. In 1870, it was found in Summertown Brick Pit, just north of Oxford, England, and it was shown to be a theropod. And then the remains were acquired by local bookseller James Parker, who brought it to John Phillips, who was an Oxford professor, and named them Eustreptospondylus, which was actually one of the most complete skeletons of a large theropod found, which is quite interesting. And then it was referred to, Megalosaurus, and that was a waste bucket taxon for a good while. And then it was split into its own thing in 1964. It split into Eustreptospondylus occidentalis, which is kind of, given its own genus. The holotype dates, as I mentioned, from about 160 million years ago, and it is quite complete, which is quite good, so we've got a pretty good idea of what it looks like. The holotype was actually fully prepared in 1924. In 2000, they found only minor difference in the hip bones, which made it different previously from Magnosaurus, so that was kind of lumped as well. So it's kind of had a little bit of a taxonomic history there. We'll talk about its description. So Eustreptospondylus was not fully grown, the main specimen, but it was about 4.6 meters long, or 15 feet long, and weighed about 218 kilograms. And it was described to be an adult, average size, and then they tried to estimate an adult size, potentially of about 6 meters, about half a ton. And the skull of Eustreptospondylus is actually rather pointed, snout and side view, with a large horizontal nasals, no lacrimal horns, but a thick skull roof, which is quite interesting. And in terms of its classification, it was originally as, Megalosauridae, and it's still kind of considered Megalosauridae, though it is in its own separate group called Eustreptospondylidae, and I think it's actually the only member of this group, so it's actually quite basal. It is literally like just after the split of Spinosaurids and Megalosaurids, so it is very much quite basal in that group, and then you have later things like Megalosaurians, like, Torvosaurus, and then Afrovenator, and things come up later on. But yeah, still really cool. Eustreptospondylus, like many other theropods, would have fed on small dinosaurs and pterosaurs and scavenged carcasses where it lived around. You've seen Walking with Dinosaurs, I think most of you have. It's very hard to, but yeah, it's very prominent. That's probably its lifestyle. And as I mentioned at the time, it probably would have lived on an island or lived across islands and maybe able to swim between them. And very similar to things like modern Komodo dragons. They're posing theories that actually these fossils may have been swept out to sea, but maybe potentially could have been, the island hypothesis makes well. And there's been another people talking about this genus maybe being an example of insular dwarfism. So when big animals get isolated on an island, like dinosaurs, hippos, elephants, deer, so large animals get isolated on islands, they become smaller to better deal with resources. So then you get things like Eustreptospondylus, which was pretty much like a rhino-sized, Brachiosaurus. You also get things like, Paleoxodon falconi, which is like, like a quarter ton, 250 kilo elephant, which is tiny. But in 2000, David Martell and Darren Nash pointed out the betrayal is actually, they were talking about it, but actually it's like, oh no, this is actually a subadult specimen. So we don't know how big an adult is. So how can we say it's a dwarf if we don't know how big the adult is? It still could be relatively young. But yeah, I really like this new interpretation. I really like the colors on this one. That one looks nice. I like that black one. But yeah, there's a really nice, cool interpretation of Eustreptospondylus. Fits quite well. Definitely a big fan of that. So we'll let you run off and do your thing, of course. And then last but certainly not least, we've got everyone's kind of forgotten to the third of the trifecta of the big Rexes. We have got Zhuchengtyrannus magnus. Let's release him. Here's another good one. So that's actually a brilliant model. I'm quite a big fan of that. Which one should we look at? I like this. Let's look at this one. I like how he's postured. He's just got a nice posture. Look at that nice postures. Anyway, so Zhuchengtyrannus, which means Zhucheng tyrant. So these guys are a genus of Tyrannosaurus theropod from the Campanian stage of the late Cretaceous from Shandong province in China, and is a Tyrannosaurini, so it's related to Tarbosaurus and Tyrannosaurus, and it contains a single species, Zhuchengtyrannus magnus. So this species is first described by David W.E. Hone, Kebai Wang, Corwin Sullivan, Jing Zhao, Zhuzhen Chen, Dunjin Li, Suan Ji, Quan Ji, and Jin Ji. Probably butchered all of that, but anyway, we'll carry on. It was described in 2011, and the type species is Zhuchengtyrannus magnus. So the generic name comes from Zhucheng, where it was found, and tyrant, which means great or powerful, due to its large size. The holotype is known solely from a nearly complete right maxilla and left dentary, and was discovered along the Ankylosaurus holotype, and is now currently housed in the Zhucheng Dinosaur Museum. There are casts of it, though, found across the place. And then a second dentary was actually found, and originally it was found in the Carpathian, so about 73 million years ago. Second dentary and maxilla has also been collected, though it has probably hard to tell if it is from Zhuchengtyrannus or another species. But it has been found living with animals, things like Sinoceratops, hadrosaurs, potentially Zhuchengtyrannus, and ankylosaurs such as Ankylosaurus, which is interesting. The area it was found would have been a floodplain, and actually is one of the highest dinosaur bone concentrations in the world, so it would have been potentially quite a rich ecosystem, which is interesting. So Zhuchengtyrannus was a large kind of theropod, very similar to Tarbosaurus, and Tyrannosaurus, so it's estimated to be similar in size and morphology to Tarbosaurus, which is about 10 meters long and about 5 metric tons. The holotype dentary, though, is significantly smaller than the corresponding bones in Sioux, which is a large Tyrannosaurus. So they got nowhere near as big as Tyrannosaurus, but more comparable to Tarbosaurus. And they're really hard to tell apart. Some people even argue this could be, just another specimen of Tarbosaurus, potentially. There's quite possible that there's several isolated teeth from one of these quarries could be given to Tyrannosaurus zhuchenensis, or belonging to this related species. So it could potentially be lumped into Tyrannosaurus, or things like that. We're not going to get too much of that. But looking at its genetic work, looking at how it's related to other Tyrannosaurs, it is considered the most basal of the group Tyrannosaurinae, before the split of Dipletosaurinae, so it is related to Tarbosaurus and Tyrannosaurus, so it's kind of quite close in there. And that's where it kind of fits. But yeah, I really like the Zhuchengtyrannus. It really makes it quite a bit different from the other two. You can see, because we got the Tarbosaurus and the Tyrannosaurus in the game now, with some good mods. But I like this, that just helps tell it apart as well. and it looks really, really nice. I'm definitely a big fan of this. Definitely a winner, in my opinion. Nice to see some more nice mods coming out. But yeah, we'll let you run off and do your thing, of course. So next up, we've got, this one's not a remaster this time. We've got a completely new species today. So this is by Hush Rock Tree again. We have got Sarcosuchus. We'll have to admit as well, this comes in a lagoon version, so we'll talk about half of it here, and then we'll go and have a look at the lagoon version. We'll let them. I want to just watch them to go off and do their own thing, so we can get a slightly better look. Let's have a look at you there. There we are. So let's get rid of that. So this is Sarcosuchus. So Sarcosuchus, which means a flesh crocodile. These guys are an extinct genus of crocodiliform and a distinct relative of the living crocodilians. It lived during the early Cretaceous, from the late Hadvurian to the early Ebdian, so about 130 to 112 million years ago, in what is now Africa and South America. It is one of the largest pseudosuchians, and the largest possible species reached about 9 to 9.5 meters, and weighed about 3.45 to 4.3 tons, and is known from 2 species. So Imperator is the species from Niger, the African species, and Hatterai is from Brazil, though there is other material found in Africa as well, but these are potentially the 2 kind of main species we know about. So in terms of how it was found, the first remains were discovered during several expeditions by French paleontologist Albert Félix de Lampart, who's spanning from 1946 to 1959 in the Sahara, and these remains were fragments of skull, vertebrae, teeth, and scutes. But in 1964, an almost complete skull was found in Niger, but it was not until 1997 and 2000 that most of its anatomy became known to science, and this led to Paul Sereno discovering 6 new specimens as well, which is quite interesting too. As we'll get into a little bit of taxonomy, this is not a true crocodile, or like modern crocodiles, we'll get into that. They are a distant relative of living crocodilians, as I mentioned, fully grown. They have somewhat telescoped eyes, so you can see they kind of come up a little bit out of the body, out of the head there. They have 35 teeth on each side of the upper jaw and 31 on the lower jaw, with the upper jaw as being notably longer than the other ones, so they had a little bit of an overbite going on. So you can see their skull there. They've got an expansion at the front of the skull. This is called a bola. This is a great example of convergent evolution. So this has actually been compared to gharial. So gharial have a bulla as well, but however, unlike the gharia, it's only found in male gharials. These guys have been found in all Sarcosuchus skulls that have been found. That may suggest that while it was sexually dimorphic in gharials, it's not in Sarcosuchus. So that's quite interesting. And they also have dermal scales, or scales on the back and things like that, osteoderms, scutes. They are similar to those of Gophophonids, which were a group of crocodilians, like Sonosuchus and Gophophonus, which had an uninterrupted surface that started from the posterior of the neck down to the middle of the tail, as seen as Parasuchus and other more basal crocodiliforms. And it differs from the pattern in modern crocodilians, so it is not quite the same. And this gives it a way of being it's not a true crocodilian. We always talk about the size, we being paleontologist people, we like to talk about size, which says a lot. A common method of estimating size is using the length of the skull from the middle to the tip and the base of the skull, and there seems to be a strong correlation there. The largest known skull of Sarcosuchus imperator, which is the type species, is about 1.6 meters long, and the estimate would have been a specimen about 11.6 meters as well. However, extrapolation from the femur of subadult individuals, as well as measurements from the skull width, actually suggest that these guys were quite a bit smaller. So most recent estimates put the largest C. imperator specimens at about 9 meters and about 3.4 tons, based on Loschering crocodile skulls, and the higher upper is about 9.5 meters to 4.3 tons. So not quite as big as we used to think, but still bloody enormous. And I'm sure a lot of other estimates, as we get more estimates of other large crocodilians like Camarasaurus and Dinosaurs and things like that, they're all in the same range. They probably come down a bit. So in terms of its classification, it is in the group Polyphonidae, which is a group of crocodile-like reptiles, related but outside of the modern crocodiles. Things like, the living group that includes living crocodiles, alligators, and gharials. And they're like a completely different thing. And most members of this group were long, slender snouts and are aquatic. Some had been marine, some are considered to be tolerating salt water like Sarcosuchus, but there's freshwater forms as well, so it really just depends. And there was more generous. They were almost like the crocodiles before they were actual crocodiles kind of thing. They were very similar. And as I mentioned as well, there are fossils in Brazil. They were found in northeastern Brazil. They now reside in the British Natural History Museum, which is interesting as well. There's also more recent findings as well. So there's some found in Morocco and the Kem. So it is potentially a species or a genus that got quite wide. Let's see what more we got to talk about. We'll have a look at now. So that's the ones on land. We'll talk about, when we talk about their biology, we'll talk about the, the ones in the lagoon. So let's release them in the lagoon. So you see, you can now have them in the lagoon as well, swimming around, which is bloody amazing. So let's have a look at you, since you're sitting in a beautiful posy like that. So, in terms of its growth pattern, they actually looked at the growth pattern of the osteoderms. So they cut in the osteoderms and counted the lags, or lines of arrested growth. And it found that it would take about 50 to 60 years for Sarcosuchus to reach adult size. And given that extant wild crocodilians really reached these advanced ages, Sereno suggested a large size by potentially extending its period of rapid juvenile growth, and it's actually been found in other species such as Dinosaurs. And they just live longer and grow longer instead of growing faster. They just grow longer. So that's basically the best way to put it. In terms of its diet, based on the broader snout of full-grown Sarcosuchus, it's actually compared to living gharial and other species of narrow-snouted crocodile, along with, the lack of teeth, suggested it may have had a generalist diet, similar to that of things like the Nile crocodile, which has been known to take in large terrestrial prey, but these guys would have potentially eaten things like dinosaurs, fish, pretty much whatever they get their mouths around. However, though, analysis of biomechanical models of the skull suggests that unlike Dinosaurus, which was pretty much just a giant alligator, Sarcosuchus may not have been able to perform the death roll, which means it may not have been able to hunt big game, or if it did hunt big game, it wouldn't be able to dismember it doing the death roll like a lot of large crocodilians today. So it would have just eaten, it would probably eat dinosaurs, but not like doing these huge big death rolls or anything. It probably didn't have the fortitude for that. But in terms of habitat, the remains of S. inspirata have been found in, the Elzar Formation from the early Cretaceous. The stratigraphy of the region and its aquatic fauna have been found to be fluvial environments, so it's freshwater and humid. It would have lived with fishes such as Leptodes and this giant coelacanth Mostonia. It would have lived with the Iguanodontian Ludosaurus and also Aranosaurus. And also two sauropods, things like Nigerosaurus and another unnamed sauropod. And then it would have lived with Suchomimus, Eocacara, and Cryptonops. And then there's also a lot of similar species that lived in Brazil as well, another shallow environment about the same time and same habitat, and had very similar species, including the same species Leptodes and Marsona, because at this time, this was just when South America and Africa had been splitting, so they would still be quite similar species in those areas. There's even some evidence, Oxali could just be another Spinosaurus. And there's a little bit more fragmentary, but we know they had theropod and iguanodontian dinosaurs in this formation. But yeah, bloody cool. So yeah, another nice one. You can see it swimming around. Another one up there, another one over there. So we'll let them go around and swim. Why not? Watch them swim out of the way. Really awesome to see some swimming Sarcosuchus in there. So next up, we've got by Trippy 13 or Trippy 28, I think it's called, whatever they go through sometimes. I guess it's just different names, different things. We have got a really interesting fish this time. We have got Saurichthys. We'll let them swim off and do their thing. Starting to panic because, there's giant animals in here, but here we are. Let's have a look at this one. I like the colours on this one. The blue just fits it quite well. Let's just close that. There we are. Saurichthys, which is lizard fish, is its name in English, is an extinct genus of predatory ray fin fish from the Jurassic period. There's a type genus of the family Saurichthyidae from the basically Jurassic to Middle Jurassic, and is the most speciose and longest-lasting genus in its family. Its family also includes the Permian Eos Saurichthys, or the German Saurichthys from here in North America, but it could be, taxonomy, whatever. Fossils of this genus have been found all over the world except for South America and Antarctica, where they lived in both freshwater and marine environments, and the oldest fossils are from the early Jurassic. There's been about 50 different species of Saurichthys described, with a lot of different variety within them, though I think some have been lumped and things like that. I don't think anyone's actually gone through and spot them all. But in terms of exact phylogenetic position, it is thought to be close relatives of the Encephaliformes, which include the living paddlefish and sturgeons, though it has been strongly questioned in more studies, that could be a bit more basal than that. Anyway, Saurichthys was an elongate fish, kind of reminds me of a pike, was about 0.6 meters, or about 2 feet long to about a meter long. Some species also do very, very small, while others can grow to about 1.5 meters, so it depends on the species, depending on the size. Species of Saurichthys have very elongate bodies, similar to modern garfish or needlefish. The dorsal and anal fin were placed opposite to each other as well and back in the body, but the tail was symmetrical as well. These features would have made them quite powerful swimmers, and you can see that jaw is extremely long, making about 1/3 of the body length, and had a sharp beak-like tip as well. And the axial skeleton on the back had actually ossified neural and humeral arches, which was quite interesting, so that would probably allow them to, be a bit more solid. In terms of ecology, the large species as well would have been apex predators, and among the Jurassic fish, they are classically interpreted as ambush predators, suggesting they would be more like modern gars and needlefish, and they would have, stalked their prey. And some species may actually live as subsurface cruisers, like Dinosaurs. Specimens have actually shown swallowed concyphic individuals, that suggests they would have been cannibals as well. And fossil evidence in the form of a bolus of bones suggests they may have been eating small marine reptiles, like the Tanystropid Logobardosaurus, or scavenge on their carcasses, which is pretty cool. A study into the gastrointestinal tract of Saurichthys actually found similarities with modern-day rays and sharks, where they had many winding valves and things like that, which actually would have been... So it's a great example of convergent evolution. And early Jurassic species differ from later species in having more elongate post-orbital position in the skull, with Middle Jurassic species having shorter ones. So you can see this is evolutionary trend. It's not anagenesis, but parallel evolution. So different lineages of this genus evolving similar traits, as one goes extinct and things change, different ecosystems as well, which is really interesting. And looking at its reproduction, fossils of gravid females show evidence of ovoviviparity, and is the oldest example of vivipary in ray fin fishes. So vivipary is pretty much, develop the embryo inside the body and then give birth. And internal fertilization is all evidenced by the specialized pelvic fin rays of some species as well. So looking at that, and there's a lot of different species. There's really a lot of species and a lot of synonyms as well. So I can't really tell you which one is this one, but it's probably interpreted to be one of the larger ones. Larger species, of course, from the mid-Jurassic. But yeah, bloody awesome. I really do love it. Nice to see some fish coming round. Do love some fishies. I always do love that. But yeah, we'll let them run off and do their thing. But we're going to finish off with another Our Reptileano and Co mod. This is one I've been really excited to talk about. So we've got here, this is a Mosasaur. So this is the accurate Mosasaur. So let's have a look at that. Let's have a look at you. Let's see if we can get you in a slightly better angle. Going right into the kelp you are. Of course you would. You can see. No, we'll wait till you in a good position to talk about you. There we are. You can see here some of the changes. You can obviously it doesn't look so scraggly and gross, and with the big osteoderms as the game, but you can see this is actually accurate scaling. So you can see very much like varanid or snake-like in its anatomy. So you can see it's got those kind of big lips going on there. If you open its mouth, it does have the extra teeth in there, which the original one did have, but look at that. So you can see this is based... Mosasaurs are actually very, very well known for their scales. A lot of these things like Platycarpus, which actually gives us a pretty good idea of how their scales would look like, and this pretty much copies it to a T. So you can see all these really small hexagonal little scales, keeled scales going on through the body there. And you can see they come up to the hair as well. And there's different ones across the body, especially around the face here. You can see some of these scales go down and down, and then down at the bottom there. So this is actually pretty accurate to Mosasaurus, which is amazing. Big fleshy lips, going on there. Nice eye there as well. All those keeled scales down and back. You can see it's much more streamlined, things like that, and also very much a nicer tail as well, as we know that they would have had. I've already described this a couple times because we've got plenty of remakes. They would have had very shark-like or, fish-like tail fins instead of the crocodile-like ones, but much more expansive than it was described, the original Jurassic World one, based on the very complete specimens that we do have of many mosasaurs, which is really, really cool. So you can see that fits perfectly, and the scale detail is just amazing. And we've got a cloaca, another cloaca. So you can see the changes on the scales there. Looks like a big tube there, so it looks bloody amazing. I really, really do love this Mosasaurus, and it comes with quite a few cool skins. I just picked the ghost skin because it looks so nice. Here you can see those really awesome scale detail. And also another thing, the nostrils are at the middle of the skull, so there's almost like, becoming almost like basilosaurid in that effect. So a lot of, modern whales have, their blowholes up the back and the areas at the top there. Mosasaurus had it a little bit more in the middle there. You can see it's almost transitioning. It only took them 30 million years to kind of reach this point, so it's very impressive. You can see all the flesh there, very smooth, not this really craggy, not so osteoderms and things. Very smooth to keep it streamlined. Same with, all the skin as well, not too much folding. But yeah, very simple, streamlined, just to keep it swaying. But yeah, I could just sit and appreciate this for hours. I love the scale detail. And it's really nice to get a finally really awesome, accurate mosasaur in the game, and it just looks amazing. And now Reptilia, you just knock it out of the park yet again. So yeah, bloody amazing. So let's have a appreciation of that. But yeah, so yeah, thank you, Al Reptilio, as I mentioned, giving me early access to cover these. I don't know if it'll be out by the time I release this video, but if it is, awesome. If it isn't, I'll update it as soon as possible when it's out, so you can get it in the description. But yeah, thank you everyone. Thank you Master Doot. Thank you Al Reptilio and Co. Thank you Harsquark Tree. Thank you Trippy. You've all done some really awesome mods. So, yeah, I really, really, really hope you guys enjoy this video. Hope you guys like and subscribe. Always remember to get the little bell icon to get notified about anything. So, yeah, hope you guys enjoy this video. Hope you guys like and subscribe, and bye-bye.